Hello guys, Art-Teeves here. In this video, I'll cover the process of 3D modeling the simple stylized helicopter in 3dsMax 2024. Just as usual, I'll also show you the process of UV unwrapping our model in Rizom and texturing it in Substance Painter. Let's get started. I'm really proud of this video, as stylized cartoony helicopters are rare, not just as models, but also as references or tutorials. Let's change that. Note that the video is quite long, so I won't narrate the entire thing. I'll step away at points and return in different chapters. Check the table of contents in the comments below, and use the link in the description to view the model on Sketchfab. First, let's clarify the chopper's design. Though cartoony, it's grounded in key principles. Its tandem rotor setup is inspired by the Chinook helicopter. In reality, reducing the rear rotor's size is feasible but less efficient. It would demand more engine power and higher rotation speed to counter the main rotor's torque. Additionally, software would be needed to synchronize the rear rotor with the main one. The turbine design draws inspiration from Sikorsky X-2 helicopter, which features a rear pusher propeller. Since we are creating a cartoony model, we swapped the propeller for a jet engine and added turbines to the helicopter's sides. In reality, this is a poor engineering choice. Turbine airflow would disrupt the rear propeller, causing vibrations and overheating the cabin. I also tilted each turbine by 7 degrees for aesthetic reasons. I'm not a fan of sci-fi or fantasy designs that lack any grounding in reality. Call me a nerd, but I'd rather design a helicopter that could theoretically attempt a takeoff. It might not stay airborne, but it could briefly lift off. At that point, our engineers should probably grab their money and run. Anyways, let's get to modeling. Also, if you like my videos, please subscribe to my channel for more stylized content. And now, on with the show. First, let's discuss the model's structure. In this pipeline, I skip the high to low poly baking process entirely and focus on polygon modeling. The final model has about 16.7k polygons and almost double that in trees. Obviously, that's way too much for a mobile game, but absolutely fine for an indie PC game. Also, a delicate pass of manual retopology could do wonders and trim down our poly count to something like 7 to 9k polygons. But that would be a completely different story. The model consists of 14 elements, separate wheels that are supposed to rotate, retractable landing gear that is supposed to move up and down, rotatable rotors, the chair, the hull itself, and finally glass parts that will have an opacity channel, which means they shall remain separate objects. I've unwrapped the model to 3 UV maps. 2 of them were given a resolution of 4K, mainly for demo purposes, as 2K would be enough for them. Third one, the glass, has a res of 512. Also, I've used a padding of 16, which isn't the best idea. If you decide to scale your UV map size down, increasing the padding to 32 would guarantee the absence of leaks. The hull's UV map doesn't have any overlapping details. The second UV map, that covers rotors and other parts of our helicopter, requires some UV stacking, primarily because our rotors have tons of similar blades that would easily get out of control and eat up all available space on the UV map. The main hull was modeled via NURMs process with iteration count set to 2. After I prepared the form, I trimmed down the poly count manually. I really enjoy the NURMs process because it combines polygon modeling and some elements of sculpting without increasing your poly count and forcing you to use decimate and other similar approaches. Obviously, you have to pre-plan a lot if you stick to this method. As you can see, I've prepared the cavity for my frontal landing gear and also some orifices to which the wings will be attached. The only downside of this method is the fact that you don't have much control of the amount of sides of your model, which is pretty fine in the case of our chopper, as we still want to give its main cylinder enough sides for its shading to work correctly. After I convert my NURMS object to an editable poly, I remove many supporting edge loops and add a couple of new ones. The general idea behind this is the fact that we want to reduce our poly count, yet make our polygons as close to square shape as possible, for our model to animate and deform correctly, without graphical artifacts. Some of you may find this process boring, since I also meticulously remove most trees and every angon, despite the fact that modern engines handle angons just fine these days. Take your time modeling NURMs object. After it's converted to an editable poly, it won't be as easy to alter a thing or two, so the final shape of our helicopter is defined during the first step of our modeling process. After I convert my hull to an editable poly, I cut it in half and carve out some openings for landing gear, wings and lights. I used 12 sides for my lamps, maybe a bit excessive, since 10 would do the trick. The main advice for such models is to keep things nice and thick. Avoid adding excessive small details, for they increase the poly count and break the overall stylized cartoony look. Also, I wouldn't use this helicopter as a hero asset for a small game. It lacks different elements that would make it much more charismatic. Also, it is almost symmetrical, if you don't mind the wolf on its left side, which is a bit poor. I think that a proper model shall have at least 6 view sides that would expose some elements you didn't see previously, that tell its story from a slightly different angle. But it is what it is. It's essential to break symmetry now and then, even when working with some small details. For example, I've lowered one lever in the cabin and added a wolf to the pipe's side. Actually, more details would make our model much better. I continue to trim down the poly count and rework some edges over and over using the Insert Edge Loop tool, while holding the Shift key. This combo makes 3dsMax respect your existing edge flow. If some orifices have way too many side counts, we can reduce their poly count by using the Loop Select tool and collapsing each second edge. Since we are working on a flat surface, adding some trees won't impact our shading. We can even collapse the uneven amount of edges and then use the Loop Regularizer script to spherify our orifices. Every opening requires a supporting edge of clean, properly proportioned quartz. This standard applies throughout the entire mesh. The closer your polygons maintain this ideal square shape, the better your results. This becomes absolutely critical for animated models, where irregular polygons will inevitably cause deformation issues and visible artifacts during movement. For spherical vertex adjustments, I use a combination of edge constraints with strategic switching between world and local coordinate systems. When centering objects and openings, follow this workflow. First, create a supporting edge ring by shift scaling edges inward, then collapse them to a central vertex. The Select and Place tool handles final positioning, but its reliability depends entirely on proper pivot preparation. Always set up your pivots methodically. Save your file, reset transforms via Xform, collapse your modifier stack, and perform manual alignment before placement. This disciplined approach maintains precision while preserving clean topology. Sometimes the Select and Place tool doesn't quite get the angle right. That's when I switch to local coordinates and manually rotate the element. Perfect alignment isn't always necessary. In fact, a bit of controlled deformation can actually enhance the stylized look we are after. For insertable models, like our frontal lamps and lights, I follow this workflow. First, model them as separate objects, carefully matching their edge count to the surrounding geometry. Then position them into existing openings, remove their outer edge loops, and bridge the geometry to connect with the corresponding orifices. I'm adding chamfers to most intersections, partly because creating convincing textures for these areas would require advanced painting skills I haven't yet developed. While you could bake these details, hand painting achieves far better results for the stylized aesthetic I am targeting. Naturally, a realistic modeling approach would require entirely different techniques. My workflow centers on modeling the entire helicopter as a unified object. That said, many secondary elements work better as separate objects, like our propellers and landing gear, which I kept detached from the main model. This modular approach allows for flexible additions later. Each method has its trade-offs depending on your project's needs. Like I said before, good planning makes topology much easier. If you build all your openings into the base shape from the start, you can just plug in models later without any headaches. But trying to add new holes to an almost finished model, that's when things get frustrating, especially when your new openings need different number of sides than what's already there. I swap some parts of my prefabricated NURMs hull to some different cylinders in order to achieve the modular look I'm after. To do this, I give my newly created cylinder the same amount of sides as the hull has, and then simply bridge new model to the rest of the shape. If you're relatively new to Max, remember, the best way to use the Propeller tool is to only apply it to intersecting geometry, splitting it briefly from the rest of the model. This way, the tool won't mess with your topology. As mentioned earlier, it's always a good idea to surround each circular intersection with a supporting edge loop of near square polygons. Finally, make sure to not give some cylinders an excessive amount of sides. For small details, 9 to 12 sides is more than enough. Obviously, if we'll be observing our helicopter from its rear side, as in some kind of third-person view game, it would be smarter to pay a lot more attention to that side than the frontal view. In this case, we would probably enhance the looks of our rear propeller, the nozzle, and also the pipe. At this point, I don't save polygons and use double chamfers now and then. Later, I'll trim their topology down. A single chamfer is enough for most intersections, while additional chamfers enhance the smooth look of our chopper, yet send our poly count through the roof. The rear model has a massive amount of polygons, and its rotor mast has 16 sides. I did it because of the possible camera positioning behind our helicopter. I position each turbine facing 7 degrees away from our helicopter. This doesn't serve anything construction-wise, and we wouldn't want to do that in real life obviously, especially because the exhaust gases would mess with our rear rotor, not mentioning the whole physics thing. Make sure to memorize this number as you attach turbines to your hull. Their pivot points will reset, and you'll want to keep that number in mind to fix the pivot point of turbine blades. I've made 2 versions of turbine blades and chose the second one. I didn't want to add too many blades, and I also wanted to make them thicker. Also, I have a really poor idea of the proper angle of each blade. I've mirrored turbine blades onto the second turbine, which is usually incorrect. Normally both turbines rotate in one direction, unlike tandem rotors. This is especially essential in order to reduce their maintenance cost, but meh, boring details. Obviously, you don't have to model such things as separate objects. Also, I'm using Rizom to unwrap my model and stack some similar UV chucks. If you don't, you'll probably want to remove all blades but one, unwrap your model, and then copy the unwrapped part onto each missing space. If you keep your blades as separate objects that intersect the central part of your turbine, make sure they don't share any vertices or planes. Else you risk facing Z-fighting, a flickering that occurs when objects fight to appear on top of each other and your graphics card can't decide which one to show. I wanted the turbine to have 10 blades because there shouldn't be too many, and 360 degrees divides evenly by 10, avoiding fractional radius placements for the blades. When it comes to modeling turbine middle parts or lamps, I prefer to borrow curved surfaces from a sphere that has an edge count that matches the amount of side edges of the element we're working on. We can alter it by using the FFD modifier. As mentioned earlier, when it comes to chamfers, I tend to trim down their count now and then, only giving a single chamfer to most intersections, while giving smooth chamfers only to some critical elements that form the slim aesthetic of our machine. When your rotor propellers are complete, make sure to test their rotation in local coordinate system, in order to see if they don't shift along some improper axis. Also, mirroring messes with your pivot points. This is why we remember the initial rotation angle of our turbines, which is equal to 7 degrees in my case. Mind that this method I show you increases your poly count slightly. If you want to trim it down on this stage, it would be a much better idea to create your propeller blades as simple objects that intersect your main central cylinder. Next, I trim down some unwanted chamfers I've added before. Obviously, we could have baked them onto a retopologized version of our model, but that's a completely different and almost perfect workflow that lacks our speed, but excels in everything else. When it comes to wheels and landing gear, remember to not to add too many small details. This never works for stylized models. The best way to add some detail is to paint it if you can. Also, in most cases your landing gear doesn't simply move up and down. Normally it moves along some local axis, so it would be wise to memorize its rotation angle, just like in case with our propellers. Mind that all wheel supports shall be relatively thick in order to maintain our overall cartoony aesthetic. You don't want to give them too many chamfers for obvious reasons. Also, if you're working on your model in Rizom, it might be the best idea to simply unwrap one rear landing gear and then copy it onto the other side. Obviously, you don't want to integrate your landing gear supports into the rest of the helicopter, unless you are modeling them as stationary statuette-like props. You'll want to animate them at some point, and it would be much easier to do so if you can simply move them inside the helicopter on takeoff. Each wheel shall also be a separate object in order to maintain rotation. Having each part of the landing gear as a separate object simplifies its baking. We can move these objects apart from each other, practically exploiting our model so that our ambient occlusion is baked separately. Mind the center of your model's weight. Stylized or not, you don't want to make it ignore reality completely. For this, a blockout or a reference image or some modeling experience is a must. First, I've made my gear stand too thin. As you can see, you can simply scale it up at any stage and then reflect it onto the other side of your wheel by using the symmetry tool. Just a reminder, it's better to memorize its rotation angle, or even write it down somewhere, in order to keep it in mind. I've kept my landing gear as simple as possible. Obviously, if you are going to make the player or a viewer be able to look at your helicopter from the bottom, you'll want to add some extra details, like say hatch doors that open when the gear stand is out. In my case, if this helicopter will get animated at some point, I'll make my landing stands simply pull into the helicopter's hull on takeoff, right through dark bottoms of each corresponding orifice. Basically, we will simply move them along the local axis. We don't want to see wheels intersect the bottom part of the hull. This is why I gave some corresponding orifices enough depths to host the lifted wheel. The rear wheels won't go inside the hull and will simply hang at the belly of our helicopter. As you can see here, I give them some bolt details, each bolt having 8 sides. This is definitely an overkill. In fact, bolts could have been painted or baked. If you still want to add some physical detail, it's much better to give them no more than 5 sides. Also, when adding bolts the way I did, it can be a great idea to rotate each hole ever so slightly, breaking any visual symmetry or repeating patterns. Remember, it's really important to think which parts of the model will be visible to the viewer at most times. I don't think someone will keep staring at a wheel, especially not in a top-down game or a third-person game where our landing gear will be blocked from sight by the helicopter's tail. I'll resume narration in the next part of the video. The valve is created from a cylinder that has the same amount of sides as the top of the cylinder to which the valve is attached. Obviously, if you want to make the valve a rotatable element, you'll want to model it as a separate object. In that case, the amount of its sides won't matter. What matters most is to not overextend with its side count obviously, which I did in some way. None will see the valve from the bottom part. Both propellers are made the same way we modeled turbines and their blades. I started modeling them via the NURMs process. I've picked a cylinder with 6 sides as my initial shape, one side for each blade connector and one side between each blade. After the initial blockout is complete, you can only work with 120 degrees sector and later rotate its copies 2 times. I didn't consider the rotation direction of the propeller, which actually matters a lot. In tandem rotor design, propellers shall rotate in different directions. Obviously, we want to create our propellers as separate elements in order to animate their rotation later on. Also, we don't want to make our propeller blades straight. This especially refers to our main rotor. These guys weigh a lot, so they are slightly bent, which can be achieved by applying an FFD modifier. The best advice here is to model a single element of your propeller flawlessly, till you are satisfied with its smoothing groups, shading, and other factors before copying it. As I've mentioned earlier, I gave each frontal lamp 12 sides, which might be a bit excessive. Cutting them down to say 9 sides wouldn't give us much, however, plus it would make these elements too edgy. I create lamps from 12-sided spheres to easily connect them to existing geometry, nothing special about it. Obviously, if you want to make lamps more realistic, you may create glass for them as separate objects that will be grouped with the cabin's glass. I prefer to simply decorate hemispheres with some dust and emission. The frontal light has the same amount of sides as the whole helicopter's hull. I trim their number down slightly, but only do so on a flat surface, so that it doesn't impact the shading. Lamps are attached to the rest of the hull by using the Select and Place tool. Before I start working on the cabin, I save my file with a separate name. It's easy to damage something during a destructive modeling process. Also extract the movable part of the cabin out of the unified hull and set its pivot point to its rotation point, which is positioned slightly above our central light. Next I detach the frame of the future cabin and give it a shell modifier to add some thickness. Finally, I erase its external borders and slowly pull its edge down, forming the floor and the rear wall. Make sure that you work in the world coordinate system. I smooth out the edges of the cabin, giving them a couple of chamfers, and surround major openings with circles of near square polygons. If you are modeling your helicopter for a particular game, the best way to do so is to start modeling in reference to your character, so it's guaranteed to fit inside, and the style of your helicopter is always based on your character. Finally, I repeat the same process for the glass frame. I don't bend glass, because it will only waste our polygons, since its borders are defined by the corresponding frame. Still, I don't delete the backside of the glass, leaving two layers of glass, one facing outside while the other one is facing inwards. Later, I'll enable two sides of it in the renderer or a game engine, so that we can see the bottom of the glass when we look from the outside. The narration will continue in the next section. The main propeller is very important. It will be observed from top and also from sides. We model it the same way as we have modeled the rear one, but give it a slightly better detail. The blades are bent, and also they aren't symmetrical. One part of them is sharper, the one that is facing towards the side of our rotation. I make blades and their holders just a little bit smoother than the ones on the tail. Nothing really special about it. Just like before, we can create them as separate objects that simply intersect the central part and share UVs. I prefer to model the whole rotor as a unified object, and later stack its UVs in Rizom. I play around with some smoothing groups here, giving bolts and blades hard edges, and leaving the rest of the propeller smooth. 3 bolts that connect the top and bottom sides of the main propeller only have 8 sides each. They are covered in shade, so their shading won't matter much. I bend the propeller using the FFD modifier and rotate its copies twice by 120 degrees. I create the chair and both levers as separate objects. There's nothing really special about them, except for the fact that the chair is optimized really poorly. If you want the levers to rotate, you shall obviously model them as separate objects. Same goes for buttons you wish to press physically. I model the chair by using NURMs process. It is stylized and thick, and yet it's supposed to mimic the design of the Chinook's chair. Now mind the chair you see left from the one I model. I modeled it beforehand and didn't like it. If you are going to show your model from the inside of the cabin, I'd recommend a completely different approach, where you'd create a different cabin, a more detailed one, a more smooth one, and also one with indicators and buttons that are properly animated as separate objects and actually work. It would also have its own unique UV map, and also it would change the classical cabin only if you would sit inside the helicopter, like a lot group. The levers that surround the chair don't need more than 8 sides obviously. They'll be barely seen from the outside of the helicopter. As I've mentioned earlier, if you want them to be interactable, you shall scale their height to the height and pose of your character, and also create them as separate objects with their essential elements centered to their rotation points. Hopefully, I'll record a pipeline for that one day. The main panel is also a toy here. The horizon indicator won't rotate and the buttons won't be pressable, otherwise we would want to model them as separate objects. Also, we would probably create an animation for our screens instead of usual textures. Despite the main round screen being pretty big, I only gave it 12 sides. Both buttons only get 8 sides. You can break symmetry here and put one button below the other one. You may also want to play with their sizes. When it comes to final adjustments and checks, I group my objects, parent them to the central hull, set its pivot point to the middle of its lower part, and place the whole group to 000 scene coordinates. Then I use the selection panel to scan my meshes for remaining angons. Technically, you can also remove poles and make sure that there aren't many vertices that connect 6 or more edges. Next, I use the 3dsMax's X-View tool to scan my model for some overlapping or isolated vertices and open edges. I didn't have any overlapping vertices in this model, but I had some isolated ones in the helicopter's hull. In order to fix it, I've simply attached the hull to a newly created box, and then removed the box. This action fixes the problem in most cases. Once again, I've checked the fact that my objects intersect each other properly and don't share some planes or vertices. I've also reset the scale, rotation and X-form of most elements and set their pivot points manually, remembering their proper initial rotation angles. If you use mirroring or symmetry while modeling, it's especially important to reset the X-form of your model and make sure that there are no flipped normals remaining. Just make sure to save your file before resetting the X-form. Finally, I proceed to assign my smoothing groups. There's nothing special about it, but once you are done, you can also apply the weighted normals modifier to your model. Just make sure to set smoothing groups meticulously and mind that they will impact unwrapping. Normally, hard edges require corresponding UV splits for padding, but UV splits do not require hard edges. Hard edge placement is about controlling low poly smoothing behavior and baked normal gradation. UV seam placement is about optimizing usable texture space, while also limiting texture distortion. Bringing the two together is about balancing visual quality with resource efficiency. Using fewer hard edges in UV splits tends to be more resource efficient, but it's also important to make sure that the final product looks good. It's generally considered best practice to strategically pair and place hard edges and UV seams along natural breaks in the shapes. Normally you can avoid sharp angles and hard edges by beveling, chamfering those edges and going with everything smooth. It means more polygons, but less drastic gradients on the low poly shading for the normal map to compensate when baked. To further improve shading on beveled low poly meshes, you can use weighted normals. As I've mentioned earlier, I've split my model into 14 objects, mainly for animation purposes. These objects are unified into 3 different groups that receive different materials. Both hull and the rest groups each received 4K Reso UV maps with a padding of 16, primarily for demo purposes. It would be better for them to stay 2K with the same padding. Giving them 4K Reso with a padding of 32 is a good way to achieve proper scaling. They won't leak even if they are reduced to a 512 pixel map. The glass UV map received a tiny 512 pixel Reso. This model is relatively simple, so I've split my UVs according to existing hard edges. Then I simply exploded all cylinders and straightened everything I could straighten in Rizom, except for cones and curved parts. Make sure to straighten all hoses and pipes for obvious reasons. At some point we want to normalize our UV chucks and rescale some of them manually, considering their proportions in comparison to proportions of neighboring elements. I perform manual scaling to allocate more texture space to visually prominent elements. Conversely, I reduce the size of UV chucks that will be obscured or less visible during typical use. When adjusting UV island sizes, make sure to maintain relative proportions within the same object. It's generally good practice to keep UV size variations within 20% of neighboring elements. Always scale UV islands uniformly per element. Any uneven scaling will create visible seams that Substance Painter can't fix, no matter what tricks you try. The main hotkeys I use for this workflow is C for cut, LG for stack, Shift LG to stack overlapped, G for group, and Ctrl G to remove grouping. Finally, I repack everything I want to repack, make sure that my materials are named properly and assigned, and finish working in 3dsMax. The final thing I do in Max is explode the model. I pull all elements of my helicopter to different sides so that they don't affect each other when baking ambient occlusion. When baking my model in Substance Painter, I set the highest possible amount of rays on all tabs, set my subsampling to 16, and click the setting to use the low poly mesh as a high poly one. Since my object is exploded, I don't have to think if some elements affect each other's ambient occlusion. Also, I disabled the ID section. My texturing here is pretty lazy. We would get a maximum of this model if we actually hand painted it, but I mostly rely on some preset smart materials. Baking messes our propellers and landing gear stands, so I lower my ambient occlusion intensity in the shader settings menu. The hull, turbines and frames receive 3 different modified versions of a preset steel painted scraped dirty smart material. I've played with its global balance and grudge settings of its different layers. Remember to block out your colors first and only bring them together when you see a reference image, a pre-made color palette, or your model in general. This is much easier than trying to match colors one by one. It is also much easier to use dark and dim colors if you're a beginner than to properly pick bright ones. I've also modified this material by adding a different paint layer, applying a smart mask to it, and also applying a blur slope filter, with its intensity divider set to 10. This filter gives our paint layer a somewhat hand-painted cartoony look. I've also changed projection methods of my layer to triplanar. This setting helps to hide most visible UV seams. The cabin received a few modified versions of preset plastic materials. I've also painted the screen of the round indicator by using the follow along path tool and a fill layer. I've added another fill layer that had an opacity setting set to 75. It was a simple dark fill layer, not completely black, that also had a high roughness value, yet not 100. I've used it to paint cavities of all exhaust pipes and nozzles, and also those cavities made for landing gear. Lights were made from a default plastic dusty smart material that received an extra emissive channel. Make sure to paint them properly before adding emission, so that their textures stay in place should you decide to disable emission. Also, I've added dark emission channels to dust and dirt, the way they started blocking light coming from the plastic itself. Finally, I created a fixed paint layer, set all of its blending options to pass through, and used the clone stamp tool to conceal remaining visible UV seams. I've cut out this part of the video because it took me a lot of time. The glass layer received 2 versions of glass that had different roughness values. The second received a different grind, obviously, to add some variations to our textures. For glass to receive a proper opacity channel, we shall change our shader to PBR Metal Rough with alpha blending. I think this covers everything I wanted to mention. Helicopter detail material didn't get anything that would differ from the rest of what I just said. Thanks for watching, guys. If my videos are of use to you, be my guest and subscribe to my channel for more stylized content. And most importantly, have a great day.